So this is a Bell Punch half adder. It's distributed by a company called Sumlock, often known as a Sumlock half adder. Its model number is a 509LD. The 5 means it has the buttons 1 to 5 only, the digits 1 to 5. There are 9 columns of them. And the LD reference means that it's a decimal version, and then it's also got what's known as a round key, which basically just means that this key here is coloured differently to the other 4 in the column, which allows you to round to the next column up if you need the help to do so, and I'll explain how that's used later. Now they're called half adders because, as you can see, they only have the numbers 1 to 5 in each column. They don't have 6, 7, 8 and 9 as you would do on a full adding machine. Now I've read that the operators would not use the digits 6 to 9 very much once they were practiced at using the machine. Instead, they would keep their hand on the low part of the machine and press the buttons twice, or press a combination of buttons in order to get the higher numbers, because it was quicker to do so. So Bell Punch and other companies made these half adders. They were designed to be used as the operators wanted to use them, and also had the benefit that they were much smaller in size and much lower in weight, much easier to handle, and much easier for me to store on my shelf. Now, although they only have the numbers 1 to 5, they can be used for full addition on all numbers, and they can also be used for subtraction and multiplication. Although their strength is basically adding a list of numbers up, and it's very quick to use them. Still useful today, which is why I was especially interested in a decimal version. And I do try to use them as much as I can. They're really nice to use, and if anybody's interested in mechanical machinery, then it's something which is cool to have. So how do we use one? Well, if we want to add 248, so we type in 2, 4, and then press the 4 twice to get an 8, to 725, so 725, we then get the answer 973. Easy peasy. If you've got a long list of numbers written down, which obviously when these machines were used people would have, they would have ledgers with a long list of items to add up. It's often quicker to add the units columns before moving on to tens and hundreds, etc. But whichever way you want to do it, that is a much better way. It's a way of making sure you don't make mistakes and you don't lose your position. But these days, people rarely have those sorts of lists to add up, really. So as we've seen already, if we want to add up a list of numbers, all we have to do is to enter each number in turn on the keyboard, and the totalizer will give us the answer. So for instance, if we wanted to add 16, 32 and 148, let's put that in. So we can put in 16, 32, 148, and we get the answer 196. All good. Now the operators, a good operator would find the best ways to enter the higher numbers. So for instance, if they wanted a 6, they would enter a 3 button twice. If they wanted to add 7, a 3 and a 4, 8, 4 and a 4, and a 9, 4 and a 5. All good. And they can also do subtraction. Now they use what's called the complement method. So if we wanted to put in 137 and then subtract, say, 16 from it, we'd have 137. Now we need to find the complement of 16. Now we take 16 away from 100, we get 84. 84 is the main part of the complement, and then we put lots of nines in the front of that. And the number of nines that you want to put in would depend on the size of the number you've already entered. So because I've entered 137, I'm only going to put in 2 or 3 nines in front. So I'm going to add 9, 9, 9, and then 8, 4. I ignore everything to that side. Once I see the zeros here, I ignore everything that's created by our 999s that we put in, and the answer I get is 121. So as we would know, 137 minus 16 is 121. Now obviously we don't need any calculator to work that one out, but if we've got a list of additions and subtractions, that's what we need to do. Okay, so let's do another example of subtraction. So let's say this time we want to do 1657, and this time subtract 988 from it. So we put in our 1, 6, 5, 7. We need the complement of 988. Now this time we take it away from 1000. That would leave us 12. So 0, 1, 2. So let's put some nines in front of that. So it would be 999012. So I'm going to do 9, 9, 9, 0, 1, 2. And we get the answer 669. Again, once we get to the zeros here, to this side where we've entered in the nines, we ignore everything to that side and we just take our answer 669. We can also do multiplication. So let's do multiplication 137 times 13. Let's make it simple. So 137, that's 1. We enter it again, 137, and a third time, 137. So we've multiplied 137 by 3 so far. And then we simply shift over one column this way, and instead of doing 137 on these last 3 columns, we move over a column and put 137 in here. And so we get the answer 137 times 13 is 1781. Easy peasy. Okay, so let's do another example of multiplication, and this time something a little bit more trickier. Let's do 1089 times 245. So this time we have to split that up into 3 multiplications. We multiply by 5, then we move over a column and multiply by 4, and then move over a column again and multiply by 2. So I'm going to put in 1889 2, 3, 4, 5. Then we move over a column. 1, 3, 4, and then finally over one more column, and we do and we get the answer 266,805. So 266,805. Easy peasy. As you can see, it's quite laborious to multiply, but it can be done, but I wouldn't recommend it as your go-to calculator for multiplication. Now, I said earlier that we would look at the round function on this adder, and it's quite simple to use. It's not really necessary, but it's a feature if you want help in rounding. Now, the actual columns of keys are in different colors, as you can see, and that's because originally it was designed for grouping. So, for instance, you could take these as decimal places, and then units, tens and hundreds, and then we're into the thousands at this side. And although there's only 9 columns, the machine will add up to 10 columns of numbers. And so those could be the millions. Obviously, you don't have to use it that way. It's whatever is appropriate to your usage. But let's say that we're adding 3 numbers up: 10.243, 17.107, and 28.565. And let's say that we, at the end of it, we want to round our answer to 2 decimal places. So we enter in our first number. So 10.243. We add to that 17.107. And then we add our final number, 28.565. And we get the answer to 3 decimal places as 55.915. Now, the round button is the one that's got a different color with it. And if we want to round that to 2 decimal places, we just press that button once and then ignore anything in this last column here. And so now we read our answer as 55.92. Okay. So let's look at a different example. This time let's just punch in a number. And so if we say we had the answer 1344, and we wanted to round that to 2 decimal places, then we just press our 5 button again. We ignore anything in this column, and so our answer is 1.34. One final one. Let's do 2488. 2488. If we press the round key again to 2 decimal places, we ignore the final column here, and our answer would be 2.49. Easy.